The sunlight has about 1,000 watts per every meter squared of light. And just fundamentally based on the physics of solar cells, you can get about 30 to 32% of that if everything is perfect. Our research lab really focuses on solar energy, and our real purpose is that we want to make new materials that capture light and make electricity, and then we want to take the ones that people already use and put on their roofs, and we want to make those ones better. What we care about is the electricity output. How efficiently do they convert sunlight into electricity? We have equipment that basically can look at everything from a full solar cell all the way down to a very small, tiny piece of a solar cell. And that's one of the reasons that people work with us. We'll start at the large scale and kind of do a really rough scan of an entire solar cell. And what we're generally looking for is something that is not like the other parts of the solar cell. So it can be either something that potentially is a defect, or maybe one spot that's working really well and we want to understand why it is working well and then improve on that. So once we've finished the large scan and we've identified some interesting areas, we'll then go into our scanning electron microscope where we can zoom in to 500,000 to 1 million times and really look in detail at the structure of the solar cell and what's making it work. This is the inside of the chamber. This is our sample right here. This is where the electron beam comes down. And this is the mirror, actually, that has been inserted in the chamber. And so there's a small pinhole in the middle. The electron beam comes through, hits the sample, it luminesces, and then it goes into that mirror. And then there's fiber optics cables that are collected down that route. Then we have other detectors in here that you can see that are doing different kind of measurements. A lot of what we're doing is gathering all this data, and then we're trying to understand how that directly correlates and ties to the performance of the solar cell. If we can understand what that material and whether it was high quality and whether electrons are moving well in it, then that will tell us a lot about whether it's going to be a good solar cell or not. And then they'll incorporate that in their product, and they're hoping that will give them a competitive edge. Basically, we've tried to make a lab that we can work with people that are working in generating and manufacturing commercial solar cells that people are actually buying, all the way to the scientist that just kind of had a crazy idea and thought it would be worth exploring and has made his first prototype. We're trying to kind of work all along this spectrum so that with the main goal to make solar energy a more cost-effective, more ubiquitous source of energy. If we continue improving, we can get it to be where it's actually an energy source that can make a huge impact in everyone's daily lives. We work with a lot of groups that are either, even if they're private companies, they want to contribute to just advancing these kind of technologies. And if it's a university group, that's their mandate, right? And so as we work with different companies or different collaborators or universities, a lot of time in the end, we'll end up working back and forth, and then a lot of the research will be published. And so, maybe they found a new material that is an interesting type of solar cell that no one's really looked at before. And a lot of the times, our work with them was a key piece of understanding that and improving it to the point that it was ready to be published. And so it will go into the academic literature and be disseminated so that everyone else can see it. And we also hope that when they see it, they'll be like, hey, that was really cool what they did for them. We'd like to work with them also. So the flexibility is really important, especially in an academic setting, because you never know where the research is going to take you. You need to be able to be nimble enough to go wherever the most interesting and the most pertinent kind of research questions take you. In the end, we really think that we have built a really unique set of equipment, that our HORIBA equipment is a very key and important piece of the puzzle.